So these are some common chapter 5 energy questions for chemistry. So this one is really common. Just go through it. Energy burning this much ethanol, grams of ethanol, this many mils of water raises this many grams. Okay, the formula for all of these is Q equals mc delta T, where Q is energy in joules, where M is mass of water, where C is specific heat capacity of water, heat, and by the way, that's always 4.18. They gave it to you in the question in paper 2s. It's in section 2 of the data booklet, and it's just always that value. Delta T is just change in temperature. So they've given all of this. They're asking for the energy, so they're asking for Q. But they've given everything else. So let's go ahead and put that all in. So Q, they've given us the mass of water to be 150. By the way, we assume 1 mil of water is 1 gram, so we can just say 150 mils, that's also 150 grams. Times 4.18, they just restated it here, times the change in temperature is 10.5, because it rises by 10.5. Okay, you'll notice that this would get us our answer in energy. So why isn't that one of the answers? Okay, well, the reason for that is that gives us the amount of energy released for this many grams of ethanol. So say this number is like 500. Don't actually do that, I don't know. But 500 joules. That means that 0.250 grams of ethanol gives off 500 joules. But we don't want it for 0.250 grams of ethanol. We want it for 1 mole. We want kilojoules even. We don't even want joules. We want kilojoules per mole. So we need to get this, because Q is always in joules. So our first thing is that needs to be kilojoules. And then we need it for 1 mole, not 0.250 grams. So if we think we're talking in moles, because we want it for 1 mole, but currently we have it for 0.250 grams. So 0.250 grams to moles, because if we're talking in kilojoules per mole, we need our mass of ethanol to be in moles, is going to be, everyone knows the formula, moles is equal to mass over molar mass. Then we have moles is equal to 0.250, and our molar mass of ethanol, you just find that in the periodic table because you're given one. Ethanol is C2H6, but we can see the number here is 46, which is the same for all of these, so we can just know that it's that. 0.8 to be precise. Okay, so then we have that this much moles, because they've kept it in a fraction, so because you don't have a calculator, is for this many joules. So this much moles gets you 150 times 4.18 times 10.5. Okay, but we want 1 mole. So we want this. So it's going to be 1 times this over this. So we end up with this. But then we also want it in kilojoules. So we end up with this over 1,000 to get our kilojoules value. Okay? And dividing by 1,000 is the same as multiplying by 1 over 1,000, because you know, like if you do 10 over 5, it's the same as 10 times 1 over 5. Have you ever seen that? So you can just take the reciprocal. So that means we can then go, this is equal to 150 times 4.18 times 10.5 over the mole value that they've kept in a fraction times 1 over 1,000. And if we combine this all, that would get rid of the 1, that would still be times. That is our final answer. And that happens to be, just double checking, B. Okay? So the answer for this one is going to be B. And honestly, I'm not going to lie, you can kind of definitely get rid of this because it's temperature change, so you're not adding Kelvin. So then you're stuck between these two, and you know you were given a joule value and you want a kilojoule value, so you know the number 1000 is going to be somewhere. So you can very quickly get B just with kind of knowledge of you want a kilojoules value, and to get between those, it's the number 1000. And you can obviously eliminate C and D, so then you're just looking for the one with 1000 in it somewhere, or where something has changed by 1000. So once you kind of get used to these, you can spot the clues in the questions. They're not actually expecting you to do all this because, you know, you can eliminate the answers logically, but this does help just get a really sure method so you don't mess up anyway. Okay, that was a bit long, sorry. Question 15. What is the enthalpy change of the following reaction? Okay, these are really chill. It's basically products for reactants, products minus reactants, sorry, for everything, except in the case broken minus formed, so I guess that's kind of reactants minus products. So it's products minus reactant for anything except broken minus formed is the rule that I memorized. I'm not sure if it works everywhere though, but anyways. So we get our products is going to be, so this thing with the BR in it, that's our product. So we're going negative 156 minus our reactants is negative 36.3 plus 0.1, because you total up all your reactants, and that's these two. So what's that going to be? Okay, so that's going to be negative 36.2, right? Yeah, well, negative 156 minus that. That's going to become a plus, because that's just like the rule. And then, so it's going to be negative, it's going to be a negative number, so we can get rid of the positive ones, and then we know it's just to do that math, it's C, because you know 0.2 must be a 0.8. If it was 0.4, we'd choose this one because there's a 0.6, you know what I mean? So we're going C. Answer for this one should be C. I haven't actually I looked at this question a while ago, so I kind of forgot what the answer is, so I'm just sure it's B, and I'm sure that's C. But these are all from this paper, by the way. So maybe 95% sure I got it right. What compound has the largest value of lattice enthalpy? So you're looking for the kind of, you know, the biggest magnitude, which means we're looking for the most strongest lattice. Okay, lattice enthalpies, I believe they're always endothermic, so we're looking for the one that's going to be hardest to break because it's the largest. So if we look at Na and O, let's compare the two nonmetals. We're given oxygen and sulfur as the two nonmetals, and Na and K, sodium potassium, as the two metals. So oxygen is more electronegative than sulfur, which means it holds electrons more tightly, which means the bond is stronger, and it's also smaller. So that's just periodic trend knowledge. So it's not one with sulfur. So then now we're comparing A and B, okay? And so that means they both have oxygen, so we need to compare Na and 2, and Na and 2 are both 1 plus cations. So we look for the smaller one, and that's just the one that's higher up on the table. Okay, again, periodic trends is how you really get the answer for this one. So because Na is smaller metal and more electronegative non-metal, I'm pretty sure that's going to be A. In which reaction does entropy decrease? Okay, this is super easy. Entropy is randomness. So if you think of how random, you know, some gases all in the air, you can't think of anything. Just think of it like that, like it's random. You can't like predict where a gas is going. After gas, you have liquid. So liquid, you know, you've got some water in a cup. Maybe it's swishing around a bit. So it's a little bit random, but not too random. And then you've got an ice cube. Okay, there's nothing random about an ice cube. It sits there, it doesn't move, it's a block. So this is high entropy down here, and you just think of it logically, like a gas is crazy, it's high entropy, and an ice block is boring and still, so that's super low entropy down here. So basically we're looking at entropy decrease. So we're looking for lots of random stuff on the reactant side and lots of chill stuff on the product side. So let's have a look. So this has gone from solid to aqueous. So that's actually gone to an entropy increase. So we can't go like it got more random. This has got to solid and an aqueous to aqueous and a gas. Okay, so the aqueous is cancel out, which means we've gone from solid to a gas. That is an entropy decrease. So sorry, that's an entropy increase. So I can't go for, what's it called? B. Okay, that's also solid to gas, so entropy increase. This has gone from two gases. So it's gone from really high entropy to really low entropy. So that is a decrease. We can just lock in C and then just check D quickly. It's got solid to a solid, but then also a gas. So it's also gone to something higher because there's gas here. So we've got to get rid of that. And 17 should be C. So 17 is C, 16 is A, 15 is C, and 14 is B. But I'm not actually that sure. So check this mark scheme, and I'll probably check it after I post this video and then comment if I made a mistake, but hopefully it's chill.